So you should be here on your Desmos, and your title should be as follows: 5.6, number 9, average rate of change. Then you save it. Saving it. And then I read the text. The text says, driving at a speed of 70 miles per hour, a Mini Cooper fuel efficiency is 29 miles per gallon. If the driver shows to speed to 60 miles per hour, he will have a fuel efficiency of 34 miles per gallon. What is the average rate of change of the fuel efficiency as the speed drops from 75 miles per hour to 60 miles per hour? Who can tell me what you did? Well, what I was going to do is I wrote a note. Driving a Mini Cooper, miles per hour versus fuel efficiency. And I'm going to write the ordered pair, right? So, what is the ordered pair? 75 what? Miles per hour, comma, gives you 29 mpg. Then 60 miles per hour gives you 34 mpg. Okay. Recording. So I decided to write the definition of average rate of change up here. Average rate of change is the slope of a secant line to the data or model function. So function. Okay. The formula is m secant equals x y1 minus y2, or f of x1, 2 minus f of x1, all that divided by x2 minus x1. That's the formula, where f of x1 or 2, 1 equals y1, and f of x1, 2, equals y2. Okay. Watch. So I don't like how this looks, so I'm just going to delete that. Okay. Now, what I'm going to do is I'm going to say, okay, so I know that you can type that, yes? Okay. So now, what's your x1? 75. What's your x2? 60. What's your f of x1? 29. What's your f of x2? 34. So I'm going to make a table. And my table is going to be 75 for the x, then 60 for the x. And then for the y, it's going to be 29, then 34. And now I have to do the slope. What's the slope? The slope I said was f of, whoops. It's going to be 29, excuse me, 29 then 34, right? I put 24, it's supposed to be 34. There. So 34 minus 29. Divided by 60 minus 75, right? Wait. Okay. Okay. So this is the miles per gallon, right? So either write it like this. I can also write it like this. I can put 60 minus 75 divided by 34 minus 29. All right? So what does this mean? As, whoops, quote, as the what? as I decrease my speed by 3 miles per hour, I increase my miles per gallon by 1. Every decrease by 3 increases my efficiency by 1. Okay. Okay. Does this make sense? Okay, so let's screenshot this. And let's do another one. Find the average rate of change of y with respect to x between x equals -1 and x equals 2. That's A. And apparently I don't know how to spell between because it's in your... Okay. At y equals f of x equals x squared plus x plus 2. Okay? So, move this up here. Okay, so this I just typed it in. F of x equals x squared plus x plus 2. Find the average rate of change of y with respect to... So y is equal to f of x, right? With respect, okay. So, I need to know what... So that's going to be this. M equals, open parentheses, f of 2 minus divided by 2 minus 1. Okay, so enter the function f of x equals x squared plus x. Part A is find the average rate of change y equals f of x with respect to x between x equals 1 and 2. And here it is. The slope is f of 2 minus f of 1 divided by 2 minus 1, which is 4. That's it. It's 4. Let's write part B. What's part B? B. Draw. Whoops, I forgot to put note. Quote. B. Draw. Let me pause that. Draw what? Draw a graph. And the secant line through the 2 points, right? Okay, so I need to know what the points are. The points are, what are they? So I would like to add a table. And I know it's 1 and 2 for the x. Replace your y1 with f of x1. And that'll give you the 2 points. Move the graph over. And I can see that goes through 1, 4, and 2, 8. 8 minus 4 is 4. 2 minus 1 is 2. 4 divided by 2 is, 4 divided by 1 is 4, right? Because that's 1 and that's 4. Okay, and here you can see that it goes up 2, 4, and over 2. So slope of 4. Now how do I draw the graph? Like this. F of x equals, what's the slope? We said it was 4. X minus. Which point would you like to use? This one or this one? I'm going to use 1, 4. So that's x minus 1 because I want to go over. Then I'm going to add, whoops, and go to the right, add 4. And there's your points. I'm going to switch the color to red to match the style of the points. Then I'm going to restrict it. Well, I don't have to restrict it. I can leave it alone. And you can change the way it looks.
So, what about this?
Uh-oh. Oh, I have 2 F's. So I'm going to change this to, it's confused. I need to put G because I already used F.
Mine is not like that though. Do I still put mine to G?
Well, yeah, because I have F up here. That's the parabola. And the red one, the G is the secant line. I guess I could call it S better. The secant line is that. Okay, hold on. Okay, I took the liberties to adjust the screen so that you could see the chord. This is called the secant chord because I restricted it from 1 to 2. What we're saying is that we're using this red chord to estimate the slope of the blue line to be 4 from 1 to 2. That's what we're doing. Okay? Okay. So let's screenshot this. There, done. And let's save it. And let's do number 11. So 5.6, number 11 or number 12? Number 12 looks easier. I'm going to do number 12. Go back to 11. No, 11?
Yes.
Sin miedo? Oh, I put it in the wrong place. Okay. That's all right. Average rate of change. Okay. So adding a note. Okay. Amy takes a trip. Where is this trip? Pausing it. Okay. So average rate of change. There's that practice quiz afterwards, right there. But let's finish picking up the information that we need for number here. So I'm just going to copy and paste this.
Mister, my computer doesn't let me screenshot.
Control C, and then I'm going to go to my Desmos. And in my note, I'm going to Control V that. Thank you very much. That's easy typing. So, what is the question? How do I do this? I'm going to add a table. Saving it in case it crashes me. Here we go. So here's 5.6 number 11 average rate of change, saving it. I am going to add a note. I already went to my book on CK12 and copied this. I'm going to go back here and press Control V, and that pastes it in there. So Control C, double click to select, Control C to copy, Control V to paste. If at this moment you don't have this, that's all right. You can add it later. What I would rather have you do right now is add a table. Okay, the graph is already over here. We have to read this and understand what it means.
Let's do another table?
Well, so far we have words, and now we're going to add a table.
Table at the top.
Okay, and now, maybe I should move it to the top so I can read this. Okay, if I move the table to the top, Amy takes a trip to Chicago, so she must have started at 0, 0, right? And she drives the first 10 miles, so let's make that miles 10. So I'm going to go over here to my graph, and I'll make the x-axis miles driven. And the y is going to be speed. No? Miles per hour? Hours. Time. Actually, should be the other way around. Time
And then the other one.
in hours. And the other one's going to be, not speed, but miles. We could do speed. That'd be interesting. Miles, not miles. Miles driven.
You just put miles.
I mean,
the quotation.
Oh my goodness. I meant to say distance in miles.
Come on.
Right? No.
Hey, wait, can you go back to that place?
Hold on. Something. I lost something. Okay. How do I go back to this place? Like this. Let's pause it. Take a moment to read this, and you'll see that we can start this trip at 0 minutes, 0 miles. Then it says 10 miles at 20 miles per hour. So how far did she go? 10 miles. So, but she did that for 20 miles per hour. So,
So the next one, she goes 30.
let's think about this. She stops at McDonald's for 10 minutes for a snack. So far, we figured out that if she stops, how much time has elapsed? Or how many miles has she gone? So that's still 40. You don't add anything to it. To the one, how long did she stop? For 10 minutes. So that's an hour plus 10 minutes is 1 out of 10 minutes is out of 60 minutes in an hour, right? So that's 10/60ths that I'm adding to that. Right? Does that make sense? 10 minutes is 10 out of 60 minutes of an hour. So it's 1/6 of an hour.
Wait. What the?
Okay, she stayed at McDonald's for 10 minutes. You see the 10 minutes?
So,
But this is a fraction of an hour. So 10 out of 60 minutes.
so Mr.
Added to the 1.
So Mr. Wouldn't it be 1 and 1/6?
Yeah, I could reduce it to 1 and 1/6, but I'm going to leave it like that. It's easier to explain. Now, over here, 45 minutes or 45 miles per hour, right?
At a 45 miles per hour.
So we have to add 45 miles. What's 40 plus 45?
95.
85.
85. How long did she do this for? What's 45 divided by 45?
1.
So that's 1 more hour. So that's 2
2 hours.
plus 1/6 if you feel like reducing it. Now, that completes the table, and the graph needs help. I can't see the graph. So I need to look at my domain. On your test, I'm going to ask you, what would be a good domain window for this? From 0 to what? How many hours?
100.
It's only been how many hours so far?
2 hours.
So 100 hours? Let's look at the range. From 0 to what? I need a little bit higher than that. For 100, right? What does it represent again? Miles. Okay, here we go. No, I'm just saying that you got to decide what to label this. So we're going to label this X as what? -10 to what? 100 hours? I'm not interested in this driving thing for 100. I'm not going to drive 100 hours. Sorry. 10 hours tops to Albuquerque and back. Because you can do that in 8. But you got to eat lunch and twice and go to the bathroom. All right, anyway. This is going to go on my recording. Sad. Okay. -10. To what? To 100 is good. We got to give some space to do some predictions. The next thing is, how do you want to count? By ones, and this one by tens. So I can look at my graph. Does it look good? Or could it look better? It looks okay. I think -10 was a little bit much.
Mister, can you
I'm going to go to -2 or -1.
-1 or 2?
Well, look at the graph. It's just style. Look. See right there.
Mister, go back to the thing, please.
Okay, going back to the thing.
I'm actually trying to keep up with you.
And we're here.
I
And
can change it.
because I moved it.
I'll move it. Mister. I'm fight you. Little? Chill, mister. You're going too quick for us, princess.
Okay.
You're a pretty princess.
Okay, actually 10 hours is too much. Let's do 5. 6 then.
6,
How's that?
-2,
Negative 2 to 6, negative 40 to 100.
alrighty,
And by a step of 1 and a step of 10.
alrighty,
Got it?
yeah.
Okay. Okay, so here is another version of 5.6 number 11. Here's the table of points translated from the English. And I guess we should ask to add the note. There's your note. Amy takes a trip, and here's the table of the trip. Here are the equations of each part of the trip. And once you do that, you realize that I can find her driving, including the McDonald's. It's 85 miles in 2 and 1/6 hours. 1/6 is because it's 10 minutes out of 60, which is 10 minutes at McDonald's. And not including McDonald's, then you would have to just divide by 2, and that's 42.5. So the transform function g will give you, the orange will give you the trip without that. And it seems that you would get those 2 points. So
What?
you see that's 285. That's another way of doing it.
Skin?
Okay. So let's save it, screenshot it, or use the other one. Answer your questions. Okay. Airplane mode on. Didn't mean to do that. I meant to do.
Were you recording?
Okay, I meant to do print screen, so print screen that. Okay. And or this one. This one's better. Okay, let's pause. Okay, so saving number 12. And
Splat. Glitter. Like glitter.
okay, actually, I want the blank, new blank graph. Okay, and this has to be a note. And get rid of that. Okay, so what is number 12? Let's read it. The weight, W of T in grams, of a tumor, T weeks after it forms, is given by WT, T squared divided by 15. Find the average rate of change of the tumor growing during the 5th week after it was formed. So, if you understand that correctly, we have to write the function W of T equals, here we go. So here we are at average rate of change. I need this one here. So I'm going to copy it and go to my Desmos account and paste it here. There it is. And this, I want to make the title here. Okay, so this is T squared divided by, whoops, go to the right, divided by 15. There you go. Now, we have to find out what it is at 0. We have to find out what it is at 5 weeks. So that's what it is. To get the average rate of change, the slope of the secant, that's going to be equal to the 5th minus the start divided by, whoops, put parentheses and divided by, whoops, let's delete this, divided by 5 minus 0. So that is your average rate of change. So in 5 weeks, we okay, so 0.3333 is 0.3333 is 1/3, or 1 gram of growth per week for 3 weeks. The tumor grows 1 gram per 3 weeks time. Okay, so that is your average rate of change. It's growing 1 gram every 3 weeks under this model. Okay, and if you want to see the secant line, you can actually put it. You didn't ask you to do that, but we could do that. And that would be 0, 0 to 5, and then okay, so that's f of x1. If I had an f of x1, let's see. I should write that down. No, it's w of x1. I said w of x1. So there it is. So there's my graph. Now, to write a secant line, you have to do secant of x equals, what did I say? 1/3? 1 gram per 3 weeks. Open parentheses. Then you have to decide what point you want to use. I can use 0, 0, which would be 1/3 x. I could leave like that. And then I could tell you it's from 0, be to 0 and 5 weeks. And that's your secant line right there. It's a secant chord because I cut it off the line. Let me pause so you can reflect. Well, here, let me move it up so you can see stuff. And you can screenshot that. It's a little bit extra than what you're asked to do. You're basically asked just to figure out this ratio right here. And the rest is extra. Yeah, I can see. Okay. So let's screenshot that. And stop the video.